Hello everyone. This video is for B.Sc program 6th semester paper 8 biochemistry. In this session number 27, I am going to explain you what is energy coupling in biological reactions and biological oxidation comparison with combustion and redox potential of some of the important half reactions. Now, in the previous session, I've told you what is spontaneous reactions and also non-spontaneous reactions or exergonic reactions and endergonic reactions. With a continuation of that, today we'll learn what is this energy coupling in biological reaction. See, we have two types of reactions. Number one, exergonic, which is thermodynamically a favorable reaction. And endergonic reaction, a thermodynamically a not favorable or an unfavorable reaction. But we want the biological system, some of the reactions to be driven or the reaction has to go. In such cases, we use a concept called energy coupling reactions. Now, the phenomenon where a thermodynamically not favorable reaction, that is endergonic reaction, it can be driven in the forward reaction means it can be enabled to take place by coupling with a highly favorable reaction or exergonic reaction is known as energy coupling reaction. Or in other words, a thermodynamically not favorable reaction is made thermodynamically favorable reaction by coupling with some other reaction which is known as energy coupling reaction. Okay, you consider a reaction A giving rise to B where delta G is positive value. In reaction 2, C giving rise to D where delta G is negative. Now, when you combine these two, A plus B giving C, when you combine these two reactions, you have delta G, that is delta G1 minus delta G2 because this reaction is G2 is having a negative value. So, totally if when delta G becomes negative, you have already learned the reaction is favorable, exergonic, that is a thermodynamically favorable reaction. Such type of reactions are known as energy coupling reaction. See, in our biological system, in most of these reactions, this hydrolysis of ATP is coupled with many other reactions because you know very well, hydrolysis of ATP is a thermodynamically favorable reaction or an exergonic reaction with delta G negative value, So if you take up the first reaction of glycolysis, that is conversion of glucose to glucose 6-phosphate, whose delta G is positive, so it is thermodynamically not favorable reaction. This reaction is coupled with the hydrolysis of ATP. What is here you are doing? This reaction is coupled with the hydrolysis of ATP. If you call this as reaction A and if you call this as reaction B, you combine A plus B. So, cancel out this term here. Similar terms on the opposite side. Water, Pi. So, what you get? Glucose plus ATP giving glucose 6-phosphate plus ATP, delta G being minus 16.7 kilojoules or delta G is equal to negative value. So, when delta G becomes negative value, then the reaction becomes exergonic, spontaneous. So, such reactions are called as energy coupling reactions. So, you will be asked to write energy coupling reaction with an example. So, learn to write this reaction properly. In most of our biological system, hydrolysis of ATP is coupled with many reactions so that delta G becomes negative and the reaction is made thermodynamically favorable reaction. Such reactions are known as energy coupling reaction. Now, I am going to compare now biological oxidation with combustion. See, you know very well combustion means any substance when burnt rapidly in oxygen gives lot of heat, that is known as combustion. Okay. Here heat is produced, that is energy we call it as heat that is produced, and the original substance will be usually a fuel. Okay, and oxygen source will be an oxidizer. In a similar way, how energy is released in our biological system? It is released by transfer of a negatively charged electron from one organic compound to another organic compound or to the oxygen, and lot of energy is produced in the living cell. Okay. So, when a compound loses an electron or it is oxidized and another compound gains an electron or it gets reduced. So, this oxidation reduction reaction is main source of energy in our biological system, which is known as biological oxidation. That is a stepwise process of burning of a food materials or breakdown of a food materials in presence of oxygen to release energy through the flow of electrons is known as biological oxidation. Now, in both the cases, energy is released, here heat is released. But what is the difference between this combustion and biological oxidation is, see, biological oxidation, the reaction mainly occurs at 37 degrees centigrade. Okay. Here, combustion occurs at a very high temperature. Here, in biological oxidation, it is a stepwise process. We have got lot of enzymes, oxidation reduction reaction take place, whereas here, the sudden combustible reaction takes place suddenly without any catalyst, and you get a lot of heat is released. Okay. So the type of energy liberated is during biological oxidation, energy is liberated stepwise. Part of the energy is accumulated as a chemical energy for living process, and part is released as heat to keep the body temperature, whereas all energy is burst out as a form of heat and light. So this is the difference between or the comparison of biological oxidation with combustion. Okay. Now, if glucose undergoes combustion, what you get? You get carbon dioxide, water with the liberation of heat. When glucose undergoes biological oxidation in a multi-step process, you have learnt in glycolysis. Okay, it gives energy in the form of ATP. Okay, now after knowing the difference between this biological oxidation and combustion, to know the electron transport chain, let us understand the concept of oxidation and reduction in terms of electrons. See, oxidation means loss of electron. So, we use the word OIL. Oil means oxidation is loss. Okay. Reduction, RIG. Reduction means it is a gain of electron. So, oxidation may be addition of oxygen, removal of hydrogen, or oxidation is nothing but loss of electron. Reduction is removal of oxygen, addition of hydrogen, or gain of electron. So, remember like this, oxidation, oil, oxidation is loss. Reduction, RIG, reduction is gain of electrons. So this Fe2 plus is a ferrous ion. When it is oxidized, you get Fe3 plus. So when Fe2 plus loses an electron, it gets oxidized to Fe3 plus. When it gains an electron, it gets reduced to Fe2 plus. Okay. See, the electron lost in the oxidation is accepted by an acceptor, which is said to be reduced. See, commonly oxidation reactions are accompanied by reduction reactions, and they are called as redox reactions. So I want to throw a light now on the redox reactions in the biological system. Now, to accept an electron, it should have an electron affinity. It should have an electron affinity. This is known as the redox potential. The affinity of any species to accept an electron is measured in terms of redox potential, which is represented by E naught dash. Okay. See, low value of redox potential signifies low electron affinity. More negative value or low redox, they will have more negative value. So, are the low redox potential means they will have a greater tendency to lose electron. Okay, because why they lose electron? Because they have low electron affinity. Then what is high redox potential signifies? High redox potential signifies high electron affinity. They will have more positive values. So, more positive potential, they have a great tendency to accept electron. So, what is electron transport chain? It is a chain of protein complexes and coenzymes in the increasing order of redox potential. Now, remember, electron flows through electron transport chain in steps from the more electronegative component, means they will have low redox potential, to the more electropositive component. Now, what is this redox potential? Now, see, these are reduction potential of some biologically important half reactions. All these are known as biologically important half reactions. These are the values of standard reduction potential of biologically important reactions. Electron flows from more negative value of reduction potential to the more positive one. Now, the same showing the redox potential of some of the important couples. Now, how do you calculate the energy yield in biological redox potential? Using this equation, E is equal to E naught plus RT by NF ln of electron acceptor by electron donor. Now, you can calculate the reduction potential using this equation. G is equal to minus NF delta E. Okay, and these are the terms explained in this equation. Now, see, one of the example for this redox couple, which is one which I wanted to mainly concentrate, acetaldehyde, when reduced, it reduces to ethanol. Acetaldehyde undergoes reduction to ethanol, and NADH is converted to NAD+, or NADH is oxidized to NAD+. See, this ethanol or acetaldehyde and NAD+ and then NADH constitutes a redox couple. When there is, these are called two conjugate pairs. When there is a presence of two conjugate pairs together in a solution, the transfer of electron from donor to acceptor occurs simultaneously. Now, to calculate the redox potential of this equation, in acetaldehyde, you know very well, getting reduced to ethanol, acetaldehyde is the electron acceptor and ethanol is the electron donor. You consider the concentration of acetaldehyde to be 1 molar and concentration of ethanol to be 0.1 molar. Substitute these values in the equation, you get E is equal to minus 0.167 volts. Similarly, you know, NADH getting oxidized to NAD+. Here NAD+ is an electron acceptor and NADH is an electron donor. And consider the concentration of NADH to be 1 molar, concentration of NAD+ to be 0.1 molar. You substitute in the equation, you get E equals minus 0.35 volts. Now, change in the reduction potential delta E is E of oxidizing agent minus E of reducing agent. So, which is the oxidizing agent here? Acetaldehyde, because it is getting reduced to ethanol. Which is the reducing agent here? NADH, because it is getting oxidized to NAD+. Substitute the values, you get 0.183 volts. Gibbs free energy can be calculated using the equation minus NF delta E. Substitute, you get minus 35.3 kilojoules per mole. So, the free energy change for the conversion of acetaldehyde to ethanol in presence of NADH is minus 35.3 kilojoules per mole. So, what you have learnt in this session is, what are energy coupling reactions? With a specific example, a thermodynamically not favorable reaction is made thermodynamically favorable reaction by coupling with usually hydrolysis of ATP. In the specific example I told you is known as energy coupling reaction, and the concept of oxidation and then reduction in terms of electrons and the comparison of biological oxidation with combustion and calculation of free energy change for the conversion of acetaldehyde to ethanol in presence of NADH. Okay, thank you.